Alright, so we're back in Greenfoot here with our two cards. We had the card class and the deck class, and a card constructor generates a random card, random suit, random rank, okay, and we set the image appropriately. So I'm going to do a few other things with card and with the world file. So if we get into world first, let's get this to where we have a deck object. And what we did last webinar, really just to get this going, is we took the first two cards off the deck and put them into the world. Now, we those cards from the deck, okay, and we're also going to add those cards to an array list player and one for the dealer. So I might have to import, yeah, I do import, I'll just call this player, and this, so we work with the array list because the deck essentially has one field, which is an array list of cards. Now in the world class, we're going to have two array lists as well. So I need to import that because it's not standard. Let's see. We have java.util.arraylist. All right. So I will this deck these need to be just deleted. I think I messed the comment up, but this deck creates 52 unique cards, 4 suits, and each suit has 13 ranks, and we get all of them in a deck. Okay, so what we're going to do, we do want to get the 0th card from the deck, and we do want to add it to the world, but I'm also going to add it to player. So player, that's like player's first card. Since to keep what we've done here is got the first card from the deck to B. Now I'm going to also add it to player. Okay. Very similar for dealer. And then we want to remove those cards from the deck. So essentially we take the first, and then we want to remove those cards from the deck. So then the deck should have 48 cards after the world is constructed. We will, I guess I'll do a card C and card D to keep the same consistent here. I'll be get to add object. So I want the version of the card, but on the top. So what I'm looking at is the Y coordinate would be, instead of being 300, so 300, since the world is 400 pixels tall, 300 pixels is 100 pixels from the end, from the bottom. 400 pixels would be at the very bottom. So I want to put the Y coordinate to be at 100, which would put the card 100 pixels from the top. So our coordinates will be the same, 500 and 350. So I'll do the same thing for card D. So let's just see what it looks like first, and I'll come in and remove them. Initialize those. So whenever you create, just like I did with deck here, I create an array list of cards called player and dealer, but I can't do anything to those arrays or array lists until I initialize them. So player would be, yeah. Let me see. Somebody have a question?
I can't see your screen, Craig.
Yeah, I didn't. I never shared. That was my fault. I guess can you edit that part out? I didn't never shared my screen. I just completely forgot.
Yeah, I'll edit it out and we'll just start from scratch.
Yeah, okay. Let me get rid of this in green foot and I'll tell you to start it back again. All right, I'm going to go ahead and share it. Okay, so we're back here in Greenfoot, and last webinar we started the card class and the deck class, where a card constructor would generate would generate one random card, a random rank and a random suit, and it would also set the image appropriately. And then we created a deck class which would initialize 52 unique cards, all 4 suits, and each suit has all 13 ranks. So we're going to add a few things in the world class, in my world. And the first thing that we're going to add is an array list of cards called player. So the game's going to be played between one player and the dealer. So there's going to be 2 lists that keep track of those cards. So this would be dealer. Okay. So I have 2 array lists of cards. One's called player, one's called dealer. And it'll keep track of the cards for each. Okay. So what we've done so far is we had the 0th card and the 1st card, and we just added them to the world. Well, the next thing we're going to do is add those cards to the hands of player and dealer. And then we're going to be able to create a score method, which will be able to calculate a score based on what the cards that the player has and what the cards the dealer has. So the first thing I have to do is initialize player to be in a new array list of cards and dealer to be a new array list. If we don't do that, player and dealer are still null objects. And until we get the new keyword, which calls a constructor, it doesn't have a memory where we can add things to it. So now it is initialized, so where we can add cards to the array list. So whenever I get the card A, which is the 0th card from the deck, and I add it to the world, I'm also going to add it to player, the array list. So I'm using the add method, which adds a card object to player, the array list. Okay, this is us actually putting it into the world where we can see it. And do the same thing for B, and I'll also add player.add B. Okay. Now, so far, nothing will look any different than what it was before. We just still have 2 cards in the world, but those 2 card objects are stored in an array list called player. And I'm going to do the same thing for 2 more cards, and I'll stay consistent here with the naming. I'll do a card C. Will be deck.getCards. Got to get the cards first, and then I'll tell it what card I want. That'll be the 2nd card, which actually is the 3rd, but indices start at 0. And I'll also do D, deck.getCards.get3. I'm going to add both of them. It doesn't matter the order in which you do things, by the way, as far as whether I add it to the world first or add it to the array list, it doesn't matter. So I'm going to do dealer.add C, dealer.add D. So I put both of those 2 cards in the list, Now I want to add those 2 cards to the world where we actually see the cards whenever the game is created. So that is with the add object method. It's add object. I want to add C. And I want to, the X coordinates will be the same as the 2 cards that I started with. In fact, I might have to change those, but right now I want to stay consistent with 500, 350. And then the Y coordinate, since the Y coordinates go from 0 to 400, 300 is 100 pixels from the bottom. So to have that kind of mirror image above, I'm going to call 100. So 100 would be 100 pixels from the top, where 300 is 100 pixels from the bottom being 400. So I will call, doesn't matter what the order, 500 and then 100. That'll be my C, and then I'll add the object D to 350 and 100. So let's see what this looks like first. Okay. So we get something like that. And ultimately, the most cards that we could put in here would be 5. So it looks like it's not quite big enough to hold 5 cards right now, so I probably need to bring them closer together. And that would be the X coordinates. And I may bring the Y coordinates, closer to the edge as well. But so the one thing I will go ahead and do is change the X coordinates. I'm going to make this X coordinate bigger. I'll make both X coordinates bigger. And this X coordinate was like the 350. This X coordinate is the 500. So I'll probably make this one at 400, or excuse me, 550 maybe, which will shift it 50 pixels. And then instead of shifting this one 50 pixels to the right, I'll shift it like 100. So not only will it'll go twice this, which means there'll be less space in between them. So I'll try that. So I said the 550s, the 500s, let me make 550. And the 350s, instead of moving 50 pixels, let's move it 100 pixels. Let's go 450. Okay, let's see what that looks like. Okay, so I need the 350, the 450 looks okay, or the 550 looks okay, but the 450 is too close. So maybe let's try 425. Okay. And that should give them some space. That looks basically like what we wanted. If you wanted to bring these 2 cards out some, you could. It'd be like 530 or something like that. Okay, so I'm going to go from there. A couple of things just to talk about what I will do eventually is create a flip method for card. What the flip method will just give another image which will allow you to flip the card over to either see the front or the back. Because truly, if you were playing the dealer, you would see one of the dealer's cards. You wouldn't see both. And if the dealer ever hit again, you would not see them. So we would really put them face down, and we will. But that will be in the next webinar when we actually start getting into the act method of the game. The 2 things that I want to do in this webinar is, number 1, create the logic of how to deal with aces. That's the first thing whenever I do this with students. That's the first question they all ask. How are you going to deal with an ace? Well, the ace can either be a 1 or 11. So we'll talk about how we'll deal with that. And then we can talk about how to determine which player wins if we call the, maybe like a get winner method. So who wins out of the dealer or the player? It's the person who has closer to 21 without going over. So the person who has closest to 21 without going over would be the person who wins. And that will be based on a score. Okay? So let's get in the same world class. And right now, all we have is constructor. So what that means is this is what the world looks like whenever it is created or constructed. Looks like that. And eventually we'll have an act method in here which will tell us basically how the game gets played. The game will be played by clicking on buttons that tell you whether you want to hit or stay, and eventually tells you whether you win or not. These methods will kind of get into some of the logic of how to score a hand. So I'll create the header first, public int get score, and I'll take in an array list of card objects. Okay. So the purpose of this method is to take in an array list of card objects and get the score, and this is where we're dealing with aces. Okay. So and this is whenever I'm doing this in my class as a teacher, this is where I actually start splitting groups up. It's the first time we do it all year, but I assign one group to do a get score method, and I assign one group to do like a hit method, which will allow players to get multiple cards. And I'll assign one group to do an is winner method, which we'll do today. And the is winner just takes in 2 scores and tells you who wins. Okay, so right now we're going to get the score. So the logic behind this, or the way that I think the best way to do it, go through all the cards in the hand, and if it's not an ace, we just simply add it up. And if it is an ace, we just kind of tally it up. So at the end of we're going to use a loop to do that. At the end of the loop, we'll have 2 numbers. One number will be the sum of all the cards that are not aces, and then we'll have the number of aces. And then depending on that, I'll talk about how we can figure out what the score would be. At this point, students always want to say, well, you know what? Why don't let's prompt the user, the player, whether they want to play it as an ace or as a 1 or an 11. And I always say that changes, because if you have an ace and let's say a 5, you'd probably be saying, yeah, I have 16, 11 plus 5. But then if you get a king after hitting, you don't want to bust, so then it would be like your 10 and your 5, or your king and your 5 would be 15, your ace would be played as a 1, it'd be 16, so that changes. So the way that we go about that is we just play like the optimal way of playing aces. So I'm going to come up with 2 variables here. I'm going to call one the sum, and I'm going to call one num aces. Set them both to 0. One's like a sum variable, one's like a counter variable. So I'm going to go through all of the cards in the array list C. Now this is just my parameter. I could easily pass player to it. I can easily pass dealer to it. So this works for any array list of cards. So I'll start with a for loop starting at index 0. I is strictly less than C dot size I plus plus. This will go through all the cards. So the indice I goes through all the indices of the cards. So I will do let me create a card object. Just be C dot get I. So if you're used to dealing with arrays, which usually people learn arrays first, this would just be like C bracket I. That's the card at index I. With array list, you call it with method, so it's a get method, and it's just called the ith index. So that's card temp. So then I could do an if statement that says if temp, which is a card, and I got to think about one of my methods in card. And actually, I just thought about this. We want to access, in card, we want to access these fields. I want to figure out if that card is an ace, which would be its rank. So right now, they're set as private, which we want to keep. So I want to create something called an accessor. And an accessor will just allow me to access these 3 fields in another class. Okay, so the accessors are pretty simple. It would be public string get rank, and it just returns rank. Public string get suit, return suit, and public int get value, return value. Okay. So those are my three accessors, and I had to stop kind of there in the world because we didn't supply them, which is kind of a bad practice you need to do if you create private fields. You need to create public accessors to ensure that encapsulation is held, but you can still access them in another class. So back in the get score class, we have if temp dot get rank, which is now a string. This is the rank of the card, and to compare strings, you need to use the dot equals method, and I will pass it ace. Okay, so if it is an ace, then I'm going to do num aces plus plus, which just adds 1 to ace. And I'm going to do an else case. The else is if it's not an ace, and if it's not an else, I'm going to sum plus equals temp dot get value. Okay, so value is how much it's worth. So like if rank was a king and it's not an ace, then you would get the value of a king, which is 10, and you would add it to the sum. Remember, the value of 5 is 5, jack is 10, queen is 10, king is 10, things like that. Okay, so at the end of this for loop, whenever it is completed, I have two numbers. What's the sum, which is the sum of everything that's not an ace, and then what is the number of aces. So when you boil it down, you can never play 2 aces as 11. Because if you have 2 aces as 11, you're already at 22, and I've already gone over. So at the very most, you want to play 1 ace as an 11 at the very most. So I'll start with the very highest number of aces you can have. Num aces. If num aces is 4, there's only 4 aces in the deck. So it's possible that you have all 4 aces and then some other cards. So if there are 4 aces, then we would need to know, well, what's the sum of all the other cards? Because if I had 4 aces and a 5, with 1 low card and 4 aces, I'd play 1 as 11. So how big would it have to be? I'll do like a nested if statement here. So if num aces is 4, and if sum, so let's see, if you play 3 aces and an 11, that would be 14. 3 aces and an 11 would be 14. So as long as I have 7 or less, then I want to play, and I guess I could create a third integer here, which would just be your total. Let me do that. So if sum is less than or equal to 7, then I will do total equals the sum plus 14. That means that my sum was currently low enough to play one of them as aces. If it's an 8 or better, I have to play them all as 1s. Okay, it's because I don't have enough for an 11 in there. So else, the total is sum plus 4. And that gets rid of the case of 4 aces. So I'm going to copy that. And we'll do, okay, well, what if you had 3 aces? If you had 3 aces, then you played one of them as an 11 and 2 of them as 1s, that would be 13. So you would have to have 8 or less, then you could play a 13. But if you have more than 8, you have to play just those 3 aces as all 1s. Okay, so that's kind of how this method will work. Num aces is 2. So if you have 2 aces, then really I guess I'll do these as else's. That way I can do an else case at the end. If I have 2 aces, I could play 1 as an ace, or 1 as 11, 1 as a 1, which would be 12 points. As long as I have 9 or less as a sum. The other cards add up to 9 or less. That's 12. Otherwise, I have to play them both as ones. And remember, we don't have to have any aces, so that's not my else case. I have to do one more. Num aces is 1. Num aces is 1. So you could either, if the sum, and you could see a pattern there, is less than or equal to 10, total equals sum plus 11. So if you have 10 or less, you can play that ace as an 11. Else you have to just play it as a 1. Okay? And then my else case would just be no aces. And then it doesn't matter. Your total is just your sum. No aces. Okay, and then after that I want to return total. So that method takes care of how we can optimally play aces, either as 1s or 11s. Okay, and to get an idea, we could system.out.print, which usually is not used in a Greenfoot game. It's just a way of troubleshooting. It's going to send it to a terminal window. But I can call the get score method of the player and system.out.print get score of dealer. Now this is not during the game. This is just at creation. Again, we'll do the at method next webinar. But whenever I create this game, notice this terminal window pops up. It's the old exception. But 15 and 7. So there's my 15, there's my 7, and really I guess we're really in this case we can at least see if one ace works. So there's a little ace. So that should play a 15 and a 14 now. Yeah, 15 and 14. But again, if we had a 4 and an ace and then we got a king after a hit method, then that total should go to 15. That ace would then be played as a 1. Okay. The other helper method that we will do here, and again, today, this webinar was a lot of the logic, actually how to get the game to play, not as many bells and whistles. But the last one will be public int get winner. Now, the reason I have to make get winner as an integer is because you might think I could make it as a boolean. Either you win or you don't. It's not true because you can tie. You could win, lose, or tie. So as soon as you get 3 options, you can't condense it into a boolean. I'm just going to do like a -1, a 0, and a 1. 0 is going to be tie. -1 is going to be the dealer wins. And then 1 is going to be the player wins. Okay? So get winner, array list of card, player, and array list of card dealer. Okay, so essentially this is going to return -1, 0, or 1 depending on whether the player wins, ties, or loses. Okay, and we won't always call this method, only whenever we want to determine a winner. Because if the game is still playing, we're still hitting and getting new cards, we don't want to call it yet. But we will call it whenever we are ready to pronounce a winner. So the first thing I'll do, I guess I'll call this PL, will be get score P. Okay, get score P. Now the way that I'm calling the method that we created here, notice I had to pass the array list P as a parameter. And I'm having to do D1 and P1 just because I call these P and D. So score D. Now I actually give this method by itself, not with array list or anything, just the Blackjack method I as a test question to my students, and I give an integer here, and they return an integer. which would either be -1, 0, or 1, depending on whether the first integer 1 or the second integer 1 or whatever. And it might seem easy on the surface, but a lot of kids kind of mess it up with the logic. But the best way to do it is to start off with both players going over 21. So if P1 is greater than 21 and D1 is greater than 21, then we return 0. Here's the power of an else if statement. Else if only checks if this is not true. So if I did P is greater than 21, now what that really means, it's not the case that they both went over. This is just the player, because if they both went over, it would have returned 0 here. So this is just the player going over. So if the player goes over, the dealer doesn't, the dealer wins. So we would return -1. And the same thing, if the dealer is over 21, 1, that means the player wins. Now, and I guess they could also tie, meaning if they have the same thing. Like if they both had 18, so that could also return 0. So, we got a couple more cases. So else if, oh, this is P1 and D1. That's why it was giving me an error. So at this point, at this else if, we know that neither of the player or the dealer have busted or gone over 21. So now we will check to see if they have the same score. This would be like 17 and 17. It would return 0. So also we're making sure that like if they get 23 and 23, that would have already happened here. But this is actually when they're less than 21 or equal to 21, but they're the same. So the only other cases that we need, else if P1 is greater than D1. Remember, we know neither of them have gone over, so we just need to make sure if P1 is bigger than D1, then we return 1. The player wins. Else, if none of those things happen, that means they're both below 21 or equal to 21, but the dealer has a higher score than player 1. So that's the logic behind it. And let's see. Oh, I wonder if I called this L. 1. Yeah, I did. Okay. So now it's P1 and D1. So now we have everything to get a winner. And I actually print this out. Now we don't want a winner at the beginning of the game. This is just for troubleshooting, just like it is to get the score. But I'm going to do get winner, player, dealer. It's called get winner. Get winner. And this is going to give me a 0, 1, or a -1 based on just what their scores are at the very beginning of the game. So who wins here? It'd be the 18 is bigger than the 7, so the dealer wins. So we don't have a hit method or anything like that. That's going to come in the next webinar. But you can at least see what it is whenever it's created. And if our get score method works, that's saying 0. Oh, I just did that one wrong. This is the very last return, which is actually the dealer winning. So we went through all the whole cases, and then this is when neither one of them have busted or gone over. They're equal to 0. P1's greater, 1, and then else the dealer is actually greater, so it should return -1. Let's see it one more time. So this one actually the player has blackjack or 21 from the very beginning, so it should be 21, 5, and then +1. So 21 for the player, 5 for the dealer, and +1, meaning the player won. Okay, so next webinar, we'll add the hit and stay methods with buttons. to tell us when to stop the game, and then we'll display a message to the player whether they won or not. We'll also create a flip method for cards. The player has to see you're playing the game, so you have to see your cards. But for the dealer, you only get to see one card. So all the other cards, we're going to need a flip method to make sure we see the back of the card instead.